കുറ്റിപ്പുറം MESCE എഞ്ചിനീയറിംഗ് കോളേജിലെ വിദ്യാർത്ഥികൾ രൂപകൽപ്പന ചെയ്ത സൈനിക വാഹനമായ ആയുധയ്ക്ക് ദേശീയതലത്തിൽ അംഗീകാരം. പ്രതിരോധ വകുപ്പിന് കീഴിലെ ഡിഫൻസ് റിസർച്ച് ആൻഡ് ഡെവലപ്മെന്റ് ഓർഗനൈസേഷൻ നടത്തിയ റോബോട്ടിക് എക്സ്പോയിൽ 1ാം സ്ഥാനം ലഭിച്ചത് ആയുധയ്ക്കാണ്.
ഞങ്ങളുടെ ഫസ്റ്റ് അയൺമെന്റ് സ്യൂട്ട് ജനറേഷൻ 1 ഡെവലപ്പ് ചെയ്യുകയും ചെയ്തു.
Good morning, sir. Sir, good morning. Sir, mute ആണ്. കേൾക്കാം സർ, കേൾക്കാം. സാറ് കോളേജിൽ എത്തിയില്ലേ?
മ്യൂട്ടിലിട്ടിട്ട് പറഞ്ഞിട്ട് കാര്യമില്ലല്ലോ അല്ലേ?
അതെ
പുസ്തകം വായിക്കണ പോലെയാവും.
അതെ സർ. അപ്പൊ അത് ഒരു ടെസ്റ്റിംഗും ആയല്ലോ. സാറിന്റെ മൈക്ക് ഓഡിബിൾ ആണ്, സാറ് വിസിബിൾ ആണ്, കോളേജിലാണ്. അതെ സർ. മാസ്ക് മാറ്റി വെക്കാം, അവിടെ ആരും ഇല്ലല്ലോ സർ.
ഒരേ ഒരാളെ ഉള്ളൂ. ആൾ പ്രൊവൈഡിങ് ഗോഡ്, ഇത് മാത്രമുണ്ട്. എന്തെങ്കിലും ചെയ്യാറുണ്ടോ? നമ്മുടെ ഒന്നും ശബ്ദമൊന്നും ഇല്ലല്ലോ അല്ലേ?
ലാപ്ടോപ്പിൽ സാറ് മൊബൈലിലാണോ കയറുന്നത്, ലാപ്ടോപ്പിലാണോ സാർ?
രണ്ടിലും ഇട്ടിട്ടുണ്ട്.
അപ്പൊ സാറ് അല്ല, ഏതിന്റെങ്കിലും ഒരു വോളിയം മ്യൂട്ട് ചെയ്ത് വെച്ചാൽ മതി. ഒരെണ്ണത്തിന്റെ വോളിയം മ്യൂട്ട് ചെയ്ത് വെച്ചാൽ മതി. അപ്പൊ പിന്നെ എക്കോ ഉണ്ടാവില്ല. യെസ്, ഇപ്പൊ ക്ലിയർ ആണ് സാർ. ഇപ്പൊ ക്ലിയർ ആണ്, കേൾക്കുന്നവർക്ക് ക്ലിയർ ആണ്.
ഇത് ചെയ്താൽ നമ്മളും പൊളിയിലാവും അല്ലേ? അത് മ്യൂട്ട് ചെയ്യാം. നമസ്കാരം.
Namaste. Good morning, everybody.
Good morning, sir. Good morning, sir. Good morning.
വരുന്നില്ലേ? ചെറിയ
Good morning, Level sir.
Good morning, good morning.
Sunny sir, good morning.
Very good morning. Rajan sir, good morning. Sir മ്യൂട്ടിലാണ്. വരദൻ സാർ മ്യൂട്ടിലാണ്.
വരദൻ സാറേ,
ഗുഡ് മോർണിംഗ്.
നീണ്ട പ്രസംഗം ചെറുതാക്കിക്കൊണ്ടിരിക്കുക.
ലബ്ബ സാർ ഇന്നലെ വിളിച്ചപ്പോഴേ പറഞ്ഞു സമയം ക്രമീകരിച്ച് പോണം.
നമുക്ക് ഒരുപാട് ഫെലിസിറ്റേഷനും എല്ലാം അരമണിക്കൂർ കൊണ്ട് തീരും, കുഴപ്പമില്ല. ഈ വിഷയങ്ങളെ നമുക്കിവിടെ നമ്മുടെ സിലബസിലൊക്കെ എവിടെയൊക്കെ ഉണ്ടോ ഇത് മുഴുവൻ? ഈ ഫോട്ടോണിക്സും അതുപോലെയുള്ള കാര്യങ്ങള്
ഇലക്ട്രോണിക്സിൽ അവർക്ക് കുറച്ച് പഠിക്കാനുണ്ട്.
ഞാൻ ഇതിന്റെ സബ്ജക്ട്സ് ഒക്കെ നോക്കിയപ്പോൾ കുറച്ചെല്ലാം അഡ്വാൻസ്ഡ് ടോപ്പിക്സ് ആണ്.
അതെ സാർ, അതെ, അഡ്വാൻസ്ഡ് ടോപ്പിക് ആണ്.
അതെ, അപ്പൊ അത് നമുക്ക് എത്രമാത്രം ദഹിക്കുമെന്ന് നോക്കുമായിരുന്നു. നമ്മുടെ ദഹനശക്തി കുറവല്ലേ.
ഫിസിക്സും അങ്ങനെ എടുക്കുന്നവരുണ്ടാവും സാർ, അതിൽ ഉപയോഗിക്കുന്ന ആൾക്കാരുണ്ടാവും.
അതെ, എന്തായാലും നമ്മളിപ്പം അല്ലെങ്കിൽ നമ്മുടെ സിലബസിനകത്ത് ഇല്ലാത്ത കാര്യങ്ങളോട് പഠിക്കുക എന്നുള്ളതാണ് നമ്മുടെ ഉദ്ദേശം.
അതെ
നമസ്തേ.
നമസ്തേ സർ. നമസ്തേ സർ. നമസ്തേ.
ഗ്രേറ്റ് സർ, വെരി വെരി വെൽക്കം, വെരി വെൽക്കം സർ.
നമസ്തേ സർ.
ഗോപാലൻ എന്നാണ് എന്റെ പേര് എഴുതി കാണിച്ചിരിക്കുന്നത്.
ജി മാധവൻ സാർ ആണ്.
അതാണ് ശരി. ഓക്കെ. So we are doubly honored, sir, by your presence.
It's my pleasure. I have come there once, maybe several years back.
Yes, sir.
Yes, sir. Yes, sir. Yes, exactly.
Very nice to meet you.
9:33 തുടങ്ങാമല്ലോ.
സാർ തുടങ്ങാം, സ്റ്റാർട്ട് ചെയ്യാം. നമുക്ക് സൗണ്ട് കുറച്ച് കൂട്ടാൻ പറ്റുമോ?
Sir, good morning. Sir, good morning.
സൗണ്ട് അല്പം കൂട്ടാൻ പറ്റുമോ?
ഇല്ല, അത് ഓരോരോ കൂട്ടുകാരിലേക്ക് സൗണ്ട് ഓരോരോ കൂട്ടാനേ പറ്റും.
നമുക്കൊന്നും ചെയ്യാൻ പറ്റില്ല.
Welcome. Huge sticky problems. In there with a silent prayer. Today, 20th September, we are gathered here for the inaugural session of the 5 days faculty development program on photonics and laser organized by the Department of Science and Humanities and the Department of Mechanical Engineering in association with the Department of CS, EEE, ECE, IT, and CE. The faculty development program is sponsored by AICTE ATAL Academy, AICTE Training and Learning Academy, is committed for the development of the quality of technical education in the country by initiating various schemes launched by the Government of India, Ministry of Human Resource Development. It was felt that training with latest tools and technologies is vital to keep an institute competitive and more productive. Training is required for increasing the knowledge and skills of students to make them more employable to acquire global competencies. Now, for the welcome speech, I invite Dr. Rahmatun Nisa I, Member Board of Governors, APJ Abdul Kalam Technological University, Member Academic Council of APJ Abdul Kalam Technological University. Ma'am, please.
Thank you. Am I audible?
Yes, ma'am.
Respected General Secretary of MES, Professor B.O.J. Labasar, Honorable Chief Guest, Sri G. Madhavan Nair, former Chairman, Indian Space Research Organization, ISR. Our beloved Professor Kadavanad Muhammad, sir, Treasurer MES, Joint Secretary C.P. Muhammad, sir, Principal MES College of Engineering, Dr. A.S. Varadarajan, sir, Dr. V.S. Anni, Head of the Department, Management Studies, Coordinator of our Faculty Development Program, Dr. Sunish, Dr. Mini, Head of the Department, Science and Humanities, Dr. Nefisa, AICT Coordinator and Head of the Department of Electrical and Electronics, and other heads of departments, colleagues, and delegates from various institutions. Ladies and gentlemen, a very warm good morning to one and all. Faculty Development Program, or FDPs, aim at enriching the knowledge of faculty members through interaction with the eminent personalities from various industries and academies, which will improve the teaching learning process that eventually contributes in enhancing working efficiency of faculty members, which in turn will prove to be beneficial to the students. Thanks to AICT for funding this program. Our FDP is on photonics and laser. The field of engineering and science are growing each day. We humans have witnessed the paradigm shift from filament bulbs to LED. Actually, this topic is an interdisciplinary one. In mechanical engineering, lasers are extensively used for precision heat treatment, cladding, welding, and cutting process. Heat treatment process could be made faster and can be done in small areas compared to conventional methods. In laser welding, impurities will be very less between the joints because it is a contactless process. Laser cutting can be done at room temperature and pressure without preheating in vacuum. I am not going to in detail about this. In this 5-day long FDP, a group of eminent and renowned speakers, including academicians, practitioners, researchers, and mentors, are ready to interact with you and value-added topics regarding photonics and laser. Now let me step into my duty of welcoming all of you. I can go without saying something about our chief guest, Sri G. Madhavan Nair sir, started his career in the Tumba Equatorial Rocket Launching Station, TERS, in 1967. During his tenure of six years of chairman, ISRO secretary, 25 successful missions were accomplished. He played a decisive role in the development of the Polar Satellite Launch Vehicle, and Geosynchronous Satellite Launch Vehicle. The nation honored him with the Padma Vibhushan in 2009 and Padma Bhushan in 1998. On behalf of the college, let me proudly welcome our most respected and dynamic chief guest, Dr. G. Madhavan Nair sir, former chairman, ISRO, who is, in spite of his hectic schedule, accepted our request and joined us for inaugurating this 5-day AICT ATAL Faculty Development Program. Hearty welcome, sir. It is my pleasure to welcome Professor P.O.J. Labasar, who is the General Secretary of MES, who has always been encouraging us to do innovative things. Welcome, sir. Let me now happily welcome Professor Kadavanad Muhammad sir, also Treasurer of MES, who always stays with us as a family member. Welcome, sir. And next, let me welcome our principal, Dr. A.S. Varadarajan sir, who extended his wholehearted support for conducting this program. I also welcome Dr. V.S. Sunny, Dr. Meeni, Dr. Nafisa, and all other department heads of our college, faculty members, staff members, and other office officials. A warm welcome, everyone. It is a real blessing that I have a wonderful group of smart and vibrant people with me in the college. I proudly welcome all our team members and coordinator of this program. Dr. Sunish, welcome dears. The last but not the least, without the delegates, we cannot achieve anything. From the bottom of my heart, on behalf of college, I welcome each and every one of you. I would also like to take this opportunity to extend my sincere gratitude to all the head of the institutions and head of the departments of your colleges. Please convey my regards to them. Sorry. Once again, I welcome each and every one of you. I really hope that the coming 5 fruitful days will prove to be interesting and beneficial for all of us. I can take a quote from Nelson Mandela. Education is the most powerful weapon which you can use to change the world. Let me conclude my words by wishing you all the best. Let this program be a great success. Thank you and have a great week ahead. Jai Hind.
Thank you, ma'am. Next, we have our presidential address by respected Professor P.O.J. Lebba, Secretary of MES College of Engineering and General Secretary of MES. He is also a member of Board of Governors, APJ Abdul Kalam Technological University, and member of Academic Council of APJ Abdul Kalam Technological University. Sir, please.
A very good morning to all. I am greatly honored by the presence of our G. Madhavan Nair sir, who is an internationally known scientist and a person who cannot be compared with any other scientist. Such great achievements he has made to the country. He has contributed to the development of space technology. And I am so, as Rahmat Unisa mentioned, because I am not repeating what he is, but he is a very, very well-known person, internationally acclaimed scientist, and the area of space technology. So, sir, I offer a warm welcome from my side also as the secretary of this college. That so your presence is really that giving a lot of satisfaction and pleasure, and also it increases the importance of this 5-day program. Now, of course, this 5-day program is organized, as mentioned before, jointly by the Mechanical Engineering Department and also the Science and Humanities Department of the college, of course, with the help of other departments as a sort of interdisciplinary program. So I am quite sure that for photonics is an area which has come to in existence very recently, and it is a physical science of light waves which deals with generation and detection and manipulation of light. And of course, photonics and laser are the emerging areas of technology. Many future developments are taking place in the field and researches are going on which will radically change and improve the scientific culture of the world. These frontier areas are recent developments and will revolutionize forensic science, medical treatment, and like radiation treatment, cancer, and imaging technology. Telecommunications is another area which will be greatly benefited. I understand the course benefits, course covers very advanced topics and including solar cells, its design, fiber sensors, LED, and its recent developments, etc. I am not going to repeat what they're going to speak on, but I only say that these topics are handled by eminent and top-level experts, which is a great advantage for this program. I don't know how they managed to get these top-level people to talk to the young delegates or young teachers who are going to be greatly benefited by this 5-day program. I can only say that the invention of laser and later the laser diode radically augmented the use of photonics. And all those things you are going to hear from eminent persons, questions, and they can clear their doubts. And I don't want to extend my speech because we are going to listen to, to top level people for 5 days. And also we are waiting the talk of Professor Sri G. Madhavan Nair, a great man, I should say, that who has been consented to be present to inaugurate this function. Thank you very much. I appreciate the efforts taken by all my professors, my distinguished faculty and professors, and also the support given by our management representatives are also here. So with these few words, I wish the function all success. Thank you very much.
Thank you, sir. Now we move on to the inaugural session. With us, we have our respected and renowned Sri G. Madhavan Nair, former ISRO chairman. Speaking of him, he is an Indian space scientist. He has also been the chairman of Space Commission and chairman of governing body of Andrix Corporation, Bangalore. He was awarded the Padma Bhushan in 1998 and the Padma Vibhushan in 2009 for his excellencies. I am indeed honored and privileged to welcome him for the inaugural session. Sir, please.
Professor P.O.J. Lebba, Dr. A.S. Varadarajan, Dr. Rehamatumsa, Professor and HOD, Dr. V.A. Sunny, Dr. Mini, Dr. Naspisa, other distinguished members of the faculty and students, a very warm good morning to all of you and greetings on this occasion of your inaugurating the 5-day workshop for faculty development. It is certainly a very noble cause. As you know, the knowledge is expanding day by day, and keeping up to date with the knowledge and techniques is very important, especially when you want to pursue a proper career in the future. The days have gone where the conventional engineering or science was able to get you a decent profession. But today, it is a world of high level of specialization, and it is multidisciplinary in nature as well. It is just not only the electronics, the biology, all this combined together only, you can make a meaningful product for the future. So from that point of view, this kind of workshops is going to be highly enlightening, and I wish all success for this the workshop, and also congratulate the organizers for this excellent work. Now, the photonics, of course, is a very specialized topic, but at the same time, today it encompasses various aspects, not only of laser, but its application, the instrumentation, the sensors, the control systems, and so on. So the photonics encompasses a host of technologies associated with using the laser for practical benefits. So this is again, one should be aware of what is happening in other fields of engineering and how you can integrate all those efforts into a final system. But let me, of course, I don't have to elaborate on the origin of the laser. In 1960, the carbon dioxide laser was really the path-breaking event. And of course, I have seen those laboratories where they have one whole work table full of glassware and electronics hardware assembled together to produce a few pulses of carbon dioxide laser. But from there, we have come a long way. In 1970, the invention of light-emitting diodes has really revolutionized the entire field. the characteristics of a semiconductor device to produce the light in various monochromatic light in various bands in the infrared as well as the visible region has really brought in the new field of communication and also the instrumentation in the world. Then later, the fiber optics, again a revolutionary invention to have the light conducted over thousands of kilometers without any attenuation and use it as a means for communication. Of course, as you know, as you move to the higher frequencies like the visible or the infrared range, the bandwidth which can be covered is very large. The diodes which are capable of responding to the high frequencies coupled with the fiber optics has really become the mainstay for the global communication today. Once we are proud of the cable network connecting all over the world, but they were rather slow. But today, the internet and other services are provided through the fiber optics, which has really become the mainstay for the human civilization itself. Now, let me highlight a few points where ISRO has taken lead in the application of laser for various purposes. The classic example was our Chandrayaan mission. We wanted to have the entire mapping of the lunar surface. Of course, we used stereoscopic cameras to get the undulations, the mounds, the craters, and so on. But you know, precisely to quantify, we depend on a laser-based radar on board the satellite. So it's a very compact instrument which works like any other radar, but only in the high frequency band, in the laser, the visible laser band. And using that, we were able to precisely gauge the depth of those craters, the height of those mountains, and so on. So we have set a sort of a record as far as mapping of the moon is concerned. Again, another application where we have seen the laser has come handy is in the inertial sensors. As you know, for guiding a rocket to a precise location, either to orbit or to the other planets, etc., we require precise information about its orientation. Initially, up to about 10 years back or so, we were depending on conventional gyroscope. There's a spinning wheel with high speed, which maintains a reference orientation and its relative variation with respect to the original axis of spinning gives the directional information. But at the same time, it has suffered mainly a lot of deficiencies because it is totally dependent on the environment. The vibration, acceleration, shock, etc. affects its performance, and the precision is not that high. We were using this kind of gyroscopes in the aircrafts for navigation. Over 1 hour flight, they used to have an error of nearly 1 kilometer or so. But ISRO has taken a lead to use the laser. That is, you send a laser beam in a ring form using a set of mirrors. And when there is a relative rotation about the axis, there is a phase shift occurring. This phase shift is detected using fine sensors, and that again is processed to derive the rays. This is totally independent of the acceleration or vibration or shock, so the precision has improved very high level. To give an example, the PSLV rocket initially used to place the satellite into a 600 kilometer orbit with something like plus minus 10 kilometer dispersion and something like 0.1 degree change in the flight path. Compared to that, when we use this laser gyroscope, we could achieve something like a few hundred meters in terms of position, as well as 0.01 degree in terms of the orientation. That's the kind of improvement which was brought in by the laser gyros. Of course, the ring laser is the most accurate one to use, but for lesser accurate application, fiber optic lasers also being used. Here again, the laser beam is sent through the fiber optic in a circular fashion, and then at the end, the difference which occurs is a measure of the rays about that axis. So this information again is used many other places, even in the cell phones and other places. We use such miniature devices for such application, but accuracy is not as good as a laser-based imaging. Then came, of course, I mentioned about the laser-based radar, but at the same time, for studying the atmospheric aerosols, you know, the climate change, aerosols and carbon dioxide, these are some of the problems which are haunting us. Precise quantification of that has not been evolved to a large extent. So we have developed a technique of using this laser-based imaging system. You send out a set of pulses from the ground to the atmosphere. The scattered signal at various levels is captured, and that is analyzed to get the information about the moisture, about aerosol, about carbon dioxide, and so on. So this has become a very powerful tool in the atmospheric research in the country. So here you can see that, you know, while the technology is evolving all around the world, the Indian space program has capitalized on it, and we have taken the lead to see that this technology is put to practical use. So why I highlighted this point is we may have a lot of knowledge and information about various things, but our success depends on how we are able to shape it for meeting a specific requirement. There are millions of requirements arising out of the societal needs, whether it is improving the quality of life or making the conveniences, making the machining more accurate, and carrying out the laser surgery, and so on. So the type of problems which are around us are plenty. So how we can use this modern technology to find a solution to that is a big challenge for the engineering community. Well, as you, I don't know how many of you are aware, the first application of laser for surgery was invented by an Indian. He is actually a Calcutta-born Dr. Bhaumik, who is a IIT product, then later migrated to US. And he is a person who took a lot of patents on the subject, and he has become billionaire over a few years using that invention. Today, you know, the laser is used in the medical field very widely, whether it is in the plastic surgery or brain removal of the brain tumor or other affected parts and so on. It's almost a knife with infinite power and with zero dimension, so to say. So it can very precisely target the affected region and remove the affected cells without causing any damage to the adjacent ones. So this has been a major achievement, and laser surgery is really catching up. Similarly, as in the welcome speech, it was mentioned that about the use of these in the machinings and so on. Today, most of the components are of millimeter size, and from there to go to the microns and submicrons becomes a real challenge. No conventional instrument can do that. But whereas using the laser techniques, one can get to that kind of dimensions very precisely. Again, the material removal using the high power laser beams is a very unique technology which can be used. Again, the semiconductor manufacturing application, the masks which are required to be prepared in a submicron level. So if we want to do that, laser is the only tool which can be employed for this purpose. Laser coupled with CNC machines and computer does all these kinds of jobs. So you can see that there is plenty of applications which is evolved, and there is plenty more in front of us. I'm sure the young generation will take on this, they acquire the knowledge, fundamental knowledge, and how to apply it to solve the problems of the society. I wish all success once again for this 5-day workshop, and may God bless you. Thank you.
Thank you, sir. Now, for the principal address, we have Dr. S. Varadarajan, Principal of MES College of Engineering, Kuttippuram. Speaking of him, he is the recipient of AIMTDR Best Research Work Award 2000 and the Production Engineering Division Gold Medal of the Institution of Engineers 2001. Received Professor M. Ghani Award for the Best College Teacher of the University of Calicut and Professor Bahauddin Award for the Distinguished Teacher of Kerala 2013 for his contributions in teaching and research. I invite him to the session. Sir, please.
Thank you. Am I audible to you?
Yes,
Can you
sir.
hear me?
Yes,
Okay,
sir.
thank you. Thank you. Respected Chief Guest, the Madhavan Nair, former Chairman ISRO, respected General Secretary MES, Professor TOJ Lebbasar, respected Treasurer MES, Professor Kadavanad Muhammad Sir, respected Joint Secretary MES, Professor CP Muhammad Sir, HOD MBA, Professor VA Sunny Sir, respected HOD ME, Professor Ermatun Sir, respected HOD Triple E, Professor Nafi Sir, respected HOD SNH, Professor Bini, Program Convener, Dr. P.U. Sunish, professors, heads of the departments, and the participants. Very good morning to all of you. I am immensely glad to be here today for the inaugural ceremony of ATAL sponsored 5-day FDP on photonics and laser. Actually, faculty development programs of this sort form potential sources of information on current trends and developments in the areas related to their themes. The curriculum is not as dynamic as the skill patterns demanded by the job market, as the updates in the curriculum are taking place only in a slower phase in the present system of education followed in our country. Hence, all graduates are not immediately employable. They have to acquire additional skill sets from other sources also, apart from what they are provided by the curriculum inside the campus. The teachers must be in a position to help their students in this aspect, and FDPs of this sort are sure to help teachers in acquiring knowledge inside and across their domain. A technical FDP of this kind can be rated based on parameters like the theme of the FDP, the relevance of the theme in the present day world, its academic, professional, and commercial relevance, the topics covered and its multidisciplinary or interdisciplinary content, the panel of resource persons, and the cross-section of participants in the program. I am sure that the FDP will come on the top with reference to all the above parameters. The very theme of the FDP, that is photonics and laser, have got tremendous relevance in the present industrial world. Photonics technology is becoming an integral part of future technology. Most advanced technologies such as robotics, IoT, AI, and more largely rely on photonics. It is expected that effective and reliable photonic gadgets will soon replace the existing semiconductor devices very soon. Photonic technology is being embraced in many sectors, and the applications of photonic devices is ubiquitous in all fields, ranging from advanced science to daily life operations. The theme has got tremendous academic, professional, and commercial relevance. The FDP offers a platform to professionals and participants from different institutions to come together and share their expertise for mutual benefit. The FDP has got an array of renowned resource persons across the country and abroad who are well known in their fields for their contributions, which add tremendously to the worth of this conference. I take up this opportunity to thank them all for spending their valuable time with us. A few words about the institution hosting this program. MES College of Engineering is a 25-year-old institution belonging to a 150-member MES group of institutions consisting of professional colleges, arts and science colleges, higher secondary schools, and a medical college. The institution offers 8 UG and equal number of PG program and PhD programs also. It is an institution recognized by AICT, and all the programs have been accredited more than once by the National Bureau of Accreditation. That has tremendously increased its credibility as a premier technical institution in the state. The institution is in the process of NAC accreditation. The institution has got an innovation center that integrates the research initiatives of the institution under one roof, a new normal technology lab to develop products and processes to reduce the hardships faced in education, agriculture, and upkeeping personal and hands hygiene. It has got an educational technology center to evolve scientific methods in teaching, learning process, a community service center to make available the expertise of the institution to the society through a cluster of 50 schools and 10 polytechnic colleges around the institution, and a training academy that offers training program to teachers in other institutions. The institution has inked an MOU with AIT Bangkok to facilitate overseas collaborations and the ICT Academy for research collaborations. The unmanned soldier assistance vehicle Ayuda, developed using the facilities of the MES Innovation Center by a team of students of EEE department, won the championship in All India Druze Expo conducted by DRDO, in which 1,088 institutions, including IITs and NITs, participated. A solenoid valve controlled prosthetic leg, developed by a team of students of Mechanical Engineering Department, won international acclamation. The Bandicoot robot, developed by the Gen Robotics, a startup venture of a group of alumni of the Department of Mechanical Engineering, received global recognition. MSME has recognized the institution as an approved TBI, and more than 7 projects have been submitted in the first phase for the award of for grants. I would like to conclude with a quote from Srimad Bhagavad Gita, Tasmad Yogaya Yujyasva, Yogaha Karmasu Kaushalam. This means Karma Yoga is actually a process of attaining perfection in one's profession or what one accomplishes. Contemporary domain knowledge is the most important ingredient for attaining perfection, and this knowledge can be acquired by reading, listening, asking, and sharing. And this FDP is sure to facilitate all this. To put it briefly, the 5-day FDP has got a versatile theme, eminent personalities from premier institutions as resource persons, a very good cross-section of participants, SNH and other departments, and the wholehearted support from the ATAL. The participants and the resource persons who are present here, who are giving or sharing their expertise, are our very respected guests or adidis, and they deserve our special respect. As the head of the institution, I accord a very special welcome to all of them, and I am sure that the FDP will fulfill the expectations of all the participants. From the bottom of my heart, I thank the AICT Training and Learning Academy for funding this FDP. And I also appreciate the efforts of the convener, Dr. Piyush Sinesh, and the coordinators, Professor Shine, Professor John Paul, for their efforts in making this program a reality. And I wish the program a big success by the grace of God. Thank you all.
Thank you, sir.
Sorry for the intervention. I have another meeting to attend. So I hope you will excuse me for leaving the meeting at this stage.
Okay, sir. Thank you very much, sir. Thank you very much, sir.
Thank you, sir.
We have our felicitation. For that, I invite Professor Kadavanadi Mohammed, Treasurer, MES. Sir, please. Hello, sir.
അടുത്ത ആളിനെ വിളിക്കുക, വേറെ വിളിക്കുക.
സാർ മ്യൂട്ടിലാണ്. റെനാഡ് സാർ മ്യൂട്ടിലാണ് സാർ.
Hello, കേൾക്കുന്നില്ലേ?
Yes, sir. Now we can.
Hello, can you hear me?
Yes, sir.
Yes, yes, sir. We can hear you.
Okay. ഈ പരിപാടിയുടെ അധ്യക്ഷൻ ഏറ്റവും ബഹുമാന്യനായ MES ജനറൽ സെക്രട്ടറി ലബ്ബ സാർ, ഈ പരിപാടി ഓർഗനൈസ് ചെയ്ത MES എഞ്ചിനീയറിംഗ് കോളേജിലെ പ്രിയപ്പെട്ട അധ്യാപകരെ, നമ്മെ സംബന്ധിച്ചിടത്തോളം വളരെ ഭാഗ്യം ചെയ്ത ഒരു ദിവസമാണ് എന്നെനിക്ക് തോന്നുകയാണ്. കാരണം മലയാളികളുടെ സ്വകാര്യ അഹങ്കാരം, നമ്മുടെ രാജ്യത്തിൻ്റെ അഭിമാനം, അങ്ങനെയൊക്കെ ആയിട്ടുള്ള ശ്രീ മാധവൻ നായരെ പോലെയുള്ള ഒരാള് ഈ പരിപാടിയിൽ വന്ന് നിങ്ങളോട് സംസാരിക്കാനും നമ്മോട് സംസാരിക്കാനും വളരെ വിലപ്പെട്ട കാര്യങ്ങൾ നാമുമായി പങ്കുവെക്കാനും ഉള്ള ഭാഗ്യം സിദ്ധിച്ച ദിവസം. ഈ പരിപാടിക്ക് എല്ലാവിധ ഭാവുകങ്ങളും വിജയങ്ങളും നേർന്നുകൊണ്ട് ഞാൻ നിർത്തുന്നു.
Thank you, sir. Next, I invite Dr. V.A. Sunny, HOD Department of MBA, MES College of Engineering, Kuttippuram. Sir, please. Hello, sir.
Sir, audio. Sir, Sunny sir, audio mute. Okay.
Yes. Most respected Leba sir, Treasurer Kadavanadi sir, Joint Secretary C.P. Mohammed, and other dignitaries and participants of this program. At the very outset, I congratulate the S&H department under the leadership of Sunesh, and also the young, energetic and dynamic teachers from various parts of the country who are participating in this national FDP. A few words to the participants. As we all know, the work of a teacher is not a job or profession, but a vocation. Aristotle said, an unexamined life is not worth living. If we live without a self-introspection, which means that we are aging but not growing. Some of the old statements is not at all valid today. It is obsolete and meaningless today. For example, when we study at our younger days, one of the popular concept is knowledge is power. So what is happening today? Everything is in the fingertips of a student now. Can a teacher provide something extra to a student or not? That is the question. It's a big question. So as our chief guest pointed out, whether we could be able to convert the knowledge into wisdom or convert the knowledge into practical purposes useful either for the student or for the society. That is what is we expected from improvement. through FDPs. So a self-introspection regarding how we are teaching our students is very much required today, or the need of the hour. So I think that teaching should be learner-centered rather than teacher-centered. Still, many of us are following the method of teacher-centered teaching. So many of the teachers are not ready to give what they are going to teach tomorrow. Because if they give that, the student will go to their laptop and see what all things are there. Then there is no usefulness for the teacher to perform. So what I wish to convey to my dear young, energetic and teachers is that have a change. Change is the thing that is sure to happen in our life. But whether we are adaptable to the change or not. So a drastic change is expected from teachers with regard to their teaching process, because the term teaching itself is changing. It's a learning process actually, not teaching process happening in our days. If you look around, open your eyes and ears, what is seen outside? There are 4 phenomena. If you read the recent journals and articles, you find that there are 4 phenomena. One is the change. Change was there from time immemorial. But today, change is so quickly happening and drastic changes are also happening. So adapt to the changes is the first and primary thing that a teacher should do. The second thing, again, which is starting from C, the competition. What's the competition? The present competition, there is cutthroat competition existing between people, between countries, between religion, what all things are happening. So that is one aspect. So a teacher must convert or transform a student to compete in the modern world. That is the second C. The third C is that there is communication. But today's communication is communication explosion. So that is again a wonderful development for the teachers to follow, and so that they can be able to equip their students for their life, for their successful life. And finally, the fourth C is conflict, the fourth phenomenon. If you go through the recent journals, articles, etc., you find
Sunny sir, audio just cut ആയി തോന്നുന്നു. Sunny sir. Okay.
Audio കട്ടായി.
ഞാൻ അടുത്ത സാറിനെ വിളിക്കാം.
Okay, Najia.
Okay, sir.
Okay.
Next, with us we have Dr. Mini PP, HOD, Department of Science and Humanities, MESCE College of Engineering, Kuttippuram. Ma'am, please.
Thank you. Respected chief guests, other dignitaries and everyone present here, a warm good morning to one and all. I am extremely happy to address you all on this function. At the same time, I feel proud to be a part of the organizing department for the FDP on photonics and laser. I take this opportunity to wish a grand success for this program. I am sure each one of the participants of this FDP will carry back from here some wonderful memories of knowledge sharing. Looking forward to many more such FDPs in the future, engaging more people and on a greater level. Thank you.
Thank you, ma'am. Next, with us, we have Dr. Nafisa K, HOD, Department of EEE, MESCE College of Engineering, Kuttippuram. Ma'am, please.
Okay, thank you. Respected Chief Guest of the day, G. Madhavan Nair sir, Professor P.O.J. Lebba sir, Professor Kadavanad Mohammed sir, Professor C.P. Mohammed sir, Principal Dr. A.S. Varadarajan sir, Rahmat ma'am, Challi sir, Mini ma'am. all the heads of the departments, coordinators, Dr. Sunesh PU, Professor Shine, dear colleagues, and all the participants, a very good morning to one and all. As we are aware, photonics and laser technology is fast developing and being utilized in many fields like medical, especially in medical treatment and diagnosis, in defense like laser weapons. I hope this FDP will throw more light into the on diverse fields of this technology. I wish you a fruitful 5 days with MES College of Engineering, Kuttippuram, and I hope extract of this FDP will be reflected in your future research and academics. Thank you all.
Thank you, ma'am. To express the vote of thanks, I would like to invite Dr. Sunish PU, Program Convener of Faculty Development Program. Sir, please.
Thank you. It's my privilege to propose photo thanks to Sri G. Madhavan Nair sir. Even though he has left the meeting, we are honored to have Sri G. Madhavan Nair sir as our chief guest. And now, Lebba sir, Kadavanad sir, CP Mohammed sir. Gratitude unspeakable because the support so far to organize this program from the leading team, from our leaders, is unspeakable. And now moving on to principal, from day one onwards, the support given by principal is really appreciable, and we respect your support and cooperation, sir. And now moving on to Ramat madam, Sunny sir, Mini madam, and Nafisa madam. As I said, the support from the HODs, from other departments, being an interdisciplinary program, we have a good group of faculty members and a good supporting team of HODs to promote this program, to organize this program. On behalf of ATAL team, I express my sincere thanks to all HODs. And now we have Dr. Smagul from Institute of Energy Norway over here in this meet. I express my sincere thanks to Dr. Smagul and also on behalf of MES College of Engineering. Now we have MES Panani College Physics Department, Dr. Jairam and Professor Riaz for their support. And I express my sincere thanks to all participants who are present in the meeting. Wish you all the best. Thank you. Thank you so much.
Thank you, sir. By this, we have come to an end of the inaugural session. Now we are moving on to the session Emerging Solar Cells, Design, Applications and Challenges.
Thank you all. Thank you all. So next we are moving into the keynote session, that is Emerging Solar Cells, Design, Application and Challenges. I hope Dr. Smagul Krishno is present, sir. The next session actually is handled by an international speaker, Dr. Smagul Krishno. I hope he has joined in the meeting. Mr. Could you please update?
Dr. Smagul, can you hear me, Dr. Smagul?
Okay, we will wait for another 2 minutes so that everything will get ready. So the participants, please wait. Once our speaker is in, we will start the program as soon. Dr. Smakul Krishna, welcome, sir. Dr. Smakul, is it audible, sir? Dr. Smakul Krishna, am I audible?
Yes, sir, audible.
Okay. So let's start the session. So we are absolutely delighted and honored to have Dr. Smakul Krishna. He's a senior scientist. He's an eminent scientist. He's from the International Center for the Technology, Energy and Technology in Norway. He's a senior scientist working in the Department of Solar Energy at IFE, Norway. Now, talking about Dr. Smakul, he has been an eminent researcher, both in academics and also as a practitioner. He has been working in research in the field of solar cells. Mainly, you can see the photo here. So this photo is actually taken from this IFE website, which is a cutting-edge research center working on solar energy cells, solar cells, organic solar cells, and the latest trends in organic solar cells. So here you can see Dr. Smakul. So welcome, sir, Dr. Smakul Krishna. So here you can see he is having a photonic cell, that is hybrid nanophotonic oxidized yttrium hybrid, as it says. So it's actually used to address the challenge associated with radiative losses and to create energy efficient windows. So he's working on this cutting edge technologies, which is a well awarded FreeNATEC program. So from the behalf of MESCE College of Engineering and from the Department of Mechanical Engineering, Science and Humanities, I offer a warm welcome to Dr. Smakul, and we are lucky enough to have such an international speaker and for our faculty development program. So, sir, please. Dr. Smakul? Dr. Smakul, once you are ready means we could switch to your presentation, or if we need some time means we could arrange. Dr. Smakul Krishna, am I audible?
Yes, JB, it's audible.
Sunil sir, if you could please connect to Dr. Smakul and get ready with the presentation.
Yeah,
so that we can do it very fast.
Let me call him. Please wait for a minute. I think.
Okay, participants, please wait for just for a minute. We will start soon.
Yeah, let me call him on phone.
Yes, sir, we can see your presentation. Dr. Smagul Krishna, could you speak something so that we can check whether it is audible or not? Your screen is visible and it is in presentation mode right now. Dr. Smagul Krishna, am I audible to you? Your screen is actually visible. If you could speak something so that we can check your audibility.
So do you hear me now? Do you
Yes,
hear
sir.
me now?
Yes. Now it's audible, sir.
Good. Yes, then we can continue.
I'm not.
What?
Okay, we can continue, sir. I was just about to welcome you once again, sir. So we are having Dr. Smagul Karsno. So he's an eminent scientist in the Department of Solar Energy from the Institute for Energy Technology in Norway. So he has been an eminent researcher in the field of solar organic cells and in developing efficient windows for reducing the radiative losses. He has been awarded the FRENATEC program, project for the FRENATEC program, and he has been working on in developing such hybrid windows for reducing the radiative losses. He has published many research papers in the International Journal of High Repute, and he has also been in the editorial board for many international journals. So on behalf of our college, it is the MES College of Engineering, and from this faculty development program on photonics and laser, I wholeheartedly welcome you to this keynote session on emerging solar cells, its design, challenge, and application. Welcome, sir.
Thanks a lot for a nice introduction about me, and it's a great honor to be introduced twice. Thanks for inviting me to this event. This is second time I'm presenting different talks in the Kerala scientific community. The first my talk some time ago I think it was on January this year. It was on artificial photosynthesis, sunlight assisted CO2 to fuel conversion, and the green hydrogen generation by solar water splitting. And in today's talk, I will tell about photovoltaic technologies. However, according to the title of my talk, it's a so broad topic which cannot be in principle covered within 1 hour. But I will do my best to reduce it. First, the squeezing will be done by telling only in the first 2 generations of solar cells, and very briefly, in the sense that the rest of 2 generations I maybe wouldn't tell more, and just the first 2 generations would be more than enough for today's lecture. So as invitees introduced me, I am from the Institute for Energy Technology, which is one of the unique institutions in Norway, which is working on different energy-related research fields, such as wind energy, petroleum energy, and the solar energy, energy storage, like supercapacitors, batteries, and solar energy as well in particular. So, and the department where I'm working on, we are specialized in materials for solar cells and the solar cell development. So if we come to the first generation solar cells, they are based on silicon. And to today, there are 4 generations of solar cells. And the first ones are silicon-based, silicon wafer-based. And the silicon wafer thickness is changing now. The first silicon-based solar cells thickness was around 300 micrometer. But to today, it has been reduced quite a bit, and it has reached to 180 micrometer thick silicon. But it cannot go, but it can go in principle even below as well. Just I will tell why. If thickness is below 100 micrometer thick, then silicon's electronic structure, its indirect and light absorbing capability of silicon will be reduced if we reduce its thickness further. If band gap of silicon, since band gap of silicon is 1.1 electron volt, if we make it thinner than 180 micrometer, then those photons with 1.1 electron volt will not be absorbed, or so weakly absorbed. And then as a result, the rest photons starting from 1.9 electron volt would be more efficiently absorbed, of course. Then we would lose a lot of solar spectrum. To avoid it, we shouldn't reduce its thickness of silicon too low. But at the same time, at the same time, a community would like to reduce silicon wafer thickness to even very low value, say 10 micrometer level. But then, of course, when silicon cannot absorb at all these 1.1 electron volt energy photons, what to do then? In such case, we have to apply these light absorbing schemes like a plasmonic effect or photonic crystals. We have to apply photonic crystals approach here. Then, of course, one would enhance light absorbing capability of silicon and further reduce wafer thickness. But of course, there is another interesting question about if we further reduce the thickness of silicon, then how to handle it. Then it would be just during processing of its surface, it would start to be broken, which is very interesting question. Yes, and then why one needs, by the way, processing of silicon surface. And first of all, it's needed to make pyramids. Why pyramids? Pyramids are needed to change, to increase light pathway in silicon. One of the ways is the sunlight will be subjected to multiple reflection from the backside and from the pyramids at the front side. That would be quite helpful. And this surface processing will be done by chemicals. And by this way, efficiency enhancement for silicon cells, it was around 1-2%, which is quite okay. Yes. And the other option was to reduce light reflection from silicon. How can it be done? It can be done by applying anti-reflection coating. Anti-reflection coating is to reduce light reflection along with surface texturization. Yes, just if we clean silicon surface, then silicon reflects about 30% of sunlight. Upon using anti-reflection coating, that will be drastically reduced. So, which is quite okay. So, yes, on the left-hand side, you can see the first designs of the solar cells with screen-printed aluminum back contact and the back surface field because of aluminum diffusion inside silicon, and the texturized surface with N+ emitter layer, anti-reflection coating, and the screen-printed silver paste contact. Why passivation layer is needed? Interesting question. As you know, all and each silicon atom is surrounded by 4 silicon atoms, and bond coordination of each silicon is 4. So, however, at the surface layer, there are dangling bonds, and some bonds of silicon are not saturated. And once they are not saturated, they will create defect states in the band gap. And that would enhance charge carrier recombination. But what we want when we are doing solar cells, suppose we have N+ layer, a lot of electrons here. We would like those electrons reach metallic contacts and contribute to electrical current. What would happen if surface is not passivated, then the electrons, holes would just die at the surface states. And when these dangling bonds are capturing some atoms from the environment, and those would serve as well as recombination centers, that would be detrimental for solar cells. So we have to reduce number of recombination centers at the surface. One of the ways to do it is to passivate with a material that will be protecting the surface from the environment, first of all, and secondly, that would be reducing surface states of silicon. And then we can then achieve such a case when there will be a lot of electrons in the N region, N++ region, and too high in the emitter layer, the probability that they will reach metallic contact and contribute to electrical charge transport, it will be too high. So that's what is needed to be done. So then we move then now to the other cases. Other case is that how to make metallic contacts. So this is how, if we look at the silicon surface, okay? These very thick lines are called bus bars. And there are very thin lines, they are called fingers. So if we enlarge it, just then we will get this type of picture. And what we can say about the design, and in case of these fingers, what we can say is that electrical resistivity is proportional to specific resistance times length divided by width and to height. It means the more the height, the wider the bus bars are, the smaller the electrical resistivity is. As to length, we cannot reduce it. It should be reaching the silicon's surface. The silicon size, it should be equivalent to that. But we can tune width and the height of these bus bars, and we can control also distance between them. So those things are doable, and one can do it, such an optimization. And in the optimization, power loss will be measured all the time, and then optimal this width, optimal height of the bus bars, optimal distance between them will be found. And you can see examples in these two pictures. Yes, then also now we know yes, by the way, these are 3 bus bar solar cells. This is one of the very oldest models of solar cells. To today, companies are producing 9 bus bar solar cells. And then after 3 bus bar, companies move to 5 bus bar cells, afterwards to 9 bus bar cells. And nowadays, people are doing now the companies are producing multi-bus bar solar cells with number of bus bars exceeding 9, but the thickness and the width of these bus bars are reduced quite a lot. So these are today's trend. Then also I mentioned it, that passivation layer is needed, anti-reflection coating is needed. These passivation layers, to today, there are so many materials available that can passivate efficiently surface of silicon. One of them is silicon nitride, the other one is silicon dioxide, and also there is aluminum oxide also, which can passivate silicon's surface. Then to today, so many designs of silicon solar cells are available. One of them is the passivated emitter with the rare locally diffused cells. And the main idea here is that in the very old designs, this area contact was just made very continuous, okay? In the parallel cells, and the laser openings will be done, and the first there will be some very thin oxide layer that will passivate silicon surface first, and then small laser openings will be opened, and then aluminum will be deposited on top of the oxide layer. As a result, in these places, the surface of silicon will be well passivated. The combination can happen only in these laser opened spots. And so this is the main idea of the parallel cells. Another concept is it's a passivated emitter and rare contact PERC cells. This one is today very popular type of solar cell. Efficiency achieved is very high. Record efficiency, it's above 33%, 23%. And here, as you see, there is, I mentioned about laser openings and aluminum diffusion through passivation layer. And top of this, on top, these openings, the aluminum contact, it will be passivated. That will further influence, further reduce charge carrier combination and the metallic contact from the backside, which is really good. So, and this is now today a very popular type of solar cell produced by different companies. And the PERC solar cell came out today, but its design is quite close to the PERC cell. And then also TOPCon solar cell. This one is the latest solar cell design, which is very popular for scientific research now, although it was suggested by Fraunhofer Institute of Solar Energy Systems in 2013. And then here, phosphorus doped polycrystalline silicon is used. Yes. Yeah, and then heat cells. Heat cells still are very popular today, and it's HEAT is acronym for the heterojunction solar cells, and it's introduced by the Japanese company Sanyo in 1980s. Since then, it's very popular, and many groups are working on this type of solar cell, but not all achieved very high efficiency. Now let's move to, and also here I should mention the following, that the designs that I have listed, they are not limited to this list. There are even much more varieties of designs of the silicon-based solar cells, and there is big physics behind each of the design. And those who will be willing to work on silicon-based solar cells can just choose one and learn more in detail. And then why thin film solar cells? This is a very interesting question. As I said, silicon-based solar cells film thickness is around 180 micrometer, but this is too thick still. And if it's too thick, if thickness of silicon reduction should be accompanied by implementing additional technologies like photonic crystals or plasmonic effect, then should we choose another material that has better light absorbing capability than silicon? For example, direct bandgap semiconductors. Of course, that would possess slightly larger than silicon bandgap, like 1.5, 1.4 electron volt. And such materials are quite a bit, of course, available. And solar cells have been developed based on them already. So then, of course, those materials will absorb smaller sunlight than silicon, and efficiency are also smaller than silicon. In case of silicon, as we see just according to designs, we see design is complicated, and this is a high technology. And all these steps like chemical treatment and anti-reflection coating depositions and the passivation, they are high tech, and it requires advanced facilities like clean rooms. For example, these solar cells are produced in China or in Europe, for example, or India. How to bring them, for example, to Latin America or to Africa? Yes, this would be very expensive. And then the other idea is maybe it's okay if one opens plant in Africa. But if this is high tech, then trained manpower would be needed that would be operating all these high techs. So this is not a trivial task. Kilo, I mean. Yes, so then I would like to tell about different varieties of thin film silicon-based solar cells. One of them is the amorphous silicon solar cells. These cells were very popular in the last century and sometimes in this year as well. But the only deficiency is this material is unstable. There is the effect Stabler-Wronski effect. The material degrades during electrical charge carrier transport and during illumination of that material. So for this reason, although this is very convenient material, but unfortunately it cannot find, it's not, commercialization of this type of solar cell was not successful. The other example is cadmium telluride-based solar cells. And the company First Solar is the leading manufacturer of the cells. And to today, efficiency of the cells is above 20% already. It can be inkjet printed and so forth. But there are challenges related to the cells also. One of them is availability of tellurium. Tellurium is one of the rarest elements on the Earth. But still, it's possible to use it in the sense that there are not much consumers of tellurium. And the other issue is poisonless of cadmium. So this poisonless property of cadmium could be important if there is cadmium release. But this cadmium release is a problem itself. It could happen if temperature of usage is around 1000 degrees C. So once cadmium telluride cells have been developed already, fabricated, and if we are going to use it in terrestrial cases with around room temperature below 100 degrees C, then there will be no problem to use these cells. Yes, and otherwise, band gap of cadmium telluride is 1.44 electron volt. Light absorbing capacity is quite high, and it's bendable, and the design of it is very simple. But here, one small thing that I should mention is that when this design of the solar cell is simple as it's here, then its efficiency is below 20%. And when design is too complicated, then one can get above 21%. So it depends on. One of the issues with the cadmium telluride cells is its metallic contact. And this is a very problematic case. And nowadays, antimony, tellurium, molybdenum is used as a metallic contact. The other one is copper, indium, gallium sulfide, or it's called the CIGS cells. And with this cell, compared to cadmium telluride, one can say that this is a very complex material. The light absorber part, in the sense that it's a quaternary compound, and it will be very difficult to control the defectiveness of the lattice. There will be huge structural point defects there. So this is one of the very drawbacks from this material. The other drawback is that it contains indium. Indium is a strategic element as well, which is very expensive today. And there are a lot of advantages of this material as well. The advantages are that by partially replacing indium with gallium, one can tune bandgap of the material in very wide range from 1.1 up to 1.9 electron volt, which is quite okay. So, and to today, efficiency achieved is already above 20% with this material. And another interesting question about this material is its role of sodium. So, and it has been found that sodium plays an important role in efficiency. In case if one grows sodium-free CIGS, then one cannot get highest efficiency. There should be at least 0.1 atomic percent sodium. It should be there. Otherwise, efficiency is not going to be very high. And in case if sodium is missing, then it should be intentionally incorporated into it. So this is one of the very puzzles related to CIGS solar cells. As to deposition methods, one can choose different varieties of methods like magnetron sputtering, for example, inkjet printing, and chemical bath deposition methods, and so forth. There are too many methods of preparing solar cells and modules also. So, yes, and one more example of the thin film solar cells, which is very popular, it is copper zinc tin sulfide solar cells. This is another quaternary compound consisting of at least 4 different elements. So, and also this solar cell has been studied since 2010 to today. The largest efficiency achieved didn't exceed too much. I mean, above 13%. There is no such efficiency enhancement. Whereas theoretically predicted limit is 31 point something percent. So there is big difference to reach the theoretical limit. Whereas in case of silicon solar cells, theoretically predicted limit is 31.2%, I think. Whereas experimentally achieved efficiency is above 27, which is quite close. In case of CIGS cadmium telluride, also efficiency enhancement is quite okay. So, and also as in case of CIGS, here one can expect a lot of structural point defects, and that will strongly influence on the charge carrier recombination in the material. And one more interesting point to be mentioned with both CIGS and the CZTS-based materials is that electrical conductivity type, N-type or P-type, and they can be controlled by structural point defects. And also, you might read in the literature about the intermediate band solar cell concept, and in case of CZTS, it can be more or less easily realized by doping or by structural just the point defects or defect impurity complexes. So, yes. Yes. And as to the latest concepts on thin film solar cells, I can say about antimony selenide-based solar cells, which is one of the latest developments. And although just now several articles are coming out in different journals, the first efficiencies achieved were around 6%, but to today, the record efficiency achieved is around 9 point something. So it's quite going up. And this efficiency enhancement progress is achieved by tuning the passivation layers and by buffer layers and so forth. And one of the emerging concepts is selenium-based solar cells. And this is, by the way, classical type of solar cell. And and when selenium was discovered at first, selenium-based solar cell, and then later on silicon and the 3-5 thin film solar cells have been discovered, then community just forgot about selenium solar cell. And now they are coming back to selenium solar cells. Design is very simple, but the efficiency achieved is, of course, quite small. And a lot of work needs to be done until achieving efficiency enhancement for this type of solar cell also. So then also here it's worth to mention about 3-5 based thin film solar cell technologies. One of them is the multi-junction solar cell. Now efficiency achieved is above 37%, which is good, but price per watt for this type of cell is also very high. It is in case of silicon cells, price per watt is 0.1 cent of US dollars per watt. In case of multi-junction cells, price per watt is 250 US dollars per watt, which is very expensive. And this expensive part is coming from materials cost and from the solar cell fabrication cost as well. So, yes. And that's why community would be interested to reduce the price per watt in case of multi-junction cells. So this is briefly the lecture that I would like to present to today, and we are open for questions.
Okay, thank you, Dr. Smagul Krishna. I think you have taken enough pain and pleasure. I think you are having a bad cough for this time. Irrespective of this bad cough, you have presented it very nicely. So thank you for taking the pain and pleasure in addressing the FDP, Faculty Development Program. So the participants can please have their feedback or have their questions to Dr. Smagul. So you are welcome. Participants may please post their questions, because it's a wonderful opportunity that we are getting an international speaker to our credit. So participants, please utilize this opportunity to have your maximum questions for improvement of your research or any other academics for that matter. Participants.
So in case if they don't have questions now, they are welcome to send just the email or send by chat questions. So all channels of communication is possible.
Okay, sir, if you don't mind, I have one question. Actually, I'm not from a photonics side or from the solar cells. I am basically a thermal person. So, could you please explain that how the solar, the heat affects the performance of the solar cell? So, how adversely it affects the solar cell performance?
Yeah, this is a very interesting question, by the way, in the sense that silicon solar cells, they are capable to operate at the temperature range up to 50 degrees C. And if temperature, even like 40, 50 degrees C are not preferable for silicon, because with increasing temperature, efficiency of the silicon solar cell is going down. It's reduced. To avoid it, we have here to think about some different schemes like luminescent solar concentrators, for example, or some enhancing radiation heat, radiation properties of silicon by texturizing its surface in some specific way. So those things should be applied. And because of the very sensitivity of silicon solar cells to temperature increase, they couldn't find application in concentrator solar cells, for example. So this influence of the cell temperature of the environment, this is very critical factors.
Okay. Thank you, sir. So, one more question, sir. Sanjay Day, one of our participants, has asked that, is there any range to store the energy for the solar cells?
Storage of energy is another very interesting question, in the sense that it would be really useful to be able to store this energy, and for that maybe supercapacitors would be needed, and the available batteries, they are not they cannot satisfy at present the need for energy storage. So energy storage, it's a very important part. And to avoid it, people are, of course, considering a grid connection. But for grid connection, there are its own complications, like thinking about the converters, for example, which are again very expensive, and very strong transformators are needed. So in today's solar energy, like in the solar farm installations, the main attention will be paid where they will be installed. So the main installations will be done for these reasons around the, for example, hydroelectric stations. That would be really interesting. Then this transformators and all these other stuff wouldn't be needed. But then one should make a system that combines PV with the hydropower, for example.
Okay. Thank you, sir. I think Sanjay Day has got his answer. Now, there is another participant, Ms. Sandhya Gupta, has asked one question. Sir, is there any optimum thickness or ideal thickness for titanium oxide coating in DSSC for good efficiency?
Yeah, this is another good question. And it's about densitized solar cells, which belongs to third generation cells. And I don't know about the optimal thickness, but the requirement to porosity here would be very much important. Porosity, if it's mesoporous, that would be interesting. And also, if the charge transfer with TiO2, with the transparent conducting film, and with dyes. Those would be important, by the way, in this case, yes. But of course, TiO2's thickness is also important, and in each experiment, it should be optimized, and the optimal thickness should be found.
Okay, thank you, sir. Thank you.
Mm-hmm.
Okay, participants, if anyone needs to ask, please hurry up.
Good afternoon, Prof. Good morning. Yeah, my name is Vinod. I actually wanted to ask the suitability of each generation for building integrated plants.
I didn't get the point. Can you please repeat?
I just wanted to ask about the suitability of each generation of solar cells in building integrated power plants.
Yes. This is another very interesting question. In fact, to today, all these generations of the solar cells are utilized in building integrated PV, in window integrated PV in particular. Research is, of course, under development, even silicon-based solar cells. And as to requirements, it depends on customer. For example, in some places, for example, requirements to color. This is one very interesting question. And in case, for example, if a community would like to use silicon solar cells, okay, which is very convenient, high efficiency, and durable. On the other hand, how to control its color? This is another interesting question. So now community is working on possibility of changing its color. That can be done by changing thickness of the anti-reflection coating, or by changing the glass color also. Also, there is perovskite-based solar cells, tandem-based solar cells, and semi-transparent solar cells, for example. Okay, and their color, they are bendable. They can be just easily removed. They can be used as cotton as well, and a lot of very interesting opportunities. And depending on what customer wishes, one can select color, and a color is an interesting question. In case, for example, I had a discussion with Japanese building construction experts. I asked the same question about what color would be okay to them. So that they said just accept like a pink color, like a color of lead. Okay, because lead is available everywhere. They are saying it can be red, it can be green, it can be blue. It doesn't matter. So that's what they said. And then I paid attention to the following point. Color, it's a human perception. It depends on geographic locations where people are living. In, for example, Arabic countries, black color is very preferable. In Europe, black color is not preferable at all. In China, for example, white color is not preferable because white color cloth they are wearing when somebody is died, for example, So it depends on customer.
Okay. Thank you. So, if any other participants need to ask. Okay. So, I hope no one is there. Okay. So, thank you very much, Dr. Smagul Krishna, for your eminent speech on emerging solar cells, its design and application. So, I don't know whether you have been to India or not. If not yet, we always welcome you for the next session, for a live session in India. If possible, we could arrange a better live session for the next time so that we can interact on live. Okay, so you are almost, so you are warmly welcome to Kerala, to our college, to India. Thank you, sir. Thank you for your wonderful speech on emerging solar cells. I hope your cough could get better after this.
Yeah.
So
Thank you.
thank you.
Thank you.
Thank you so much. Thank you so much.
Bye.
So before going, I would like to call our international participant. Actually, he is from Heroit University. He's working as associate professor. So I would like to call Dr. Vinod V in order to give a word of gratitude to our eminent speaker. Sir Vinod, sir, please.
Thank you, Sharon. Yeah, thank you very much. Okay, this was very interesting, and Prof was, it shows his experience and knowledge, how he explained all the generations in simple words. I have a simple suggestion, probably for a next program or something like that. Prof, you could talk about the environmental issues. You know, when these solar plants get to and now it's an issue, environmental issue of dumping these things. So probably you can talk about how the generations are comparatively much better, and why we need to improve on the technology, material-wise, etc. Yeah, that's a suggestion, and thank you for the innovative talk and giving us more knowledge on the various generations. Thank you very much.
Thank you, Vinod V. Okay, so now we have come to the end of this session. So our next session starts in the afternoon. So it is by Dr. Pradeep P, an eminent physicist professor from the NIT Calicut. So before that, I would like Sunish sir to say a few words to the participants so that we could organize the next session.
Yes, thank you, sir. Once again, I express my sincere thanks to Dr. Smagul. It's been a tough time over there. Even in this period, he has came and delivered a session on behalf of MES College of Engineering and their faculty members. I express my sincere gratitude. Thank you, sir. And now regarding the second session, let me brief you. We have attendance Google form every day in the evening, and you are requested to enter your attendance by filling the details like your name, phone number, email ID. And now, after attendance, we will provide you the feedback session, feedback form through Google form, and you are requested to fill the Google form. So this is a continuous process till the end of the FTP. All the participants are requested to fill the attendance link or attendance form as well as the feedback form. Once we finish the FTP, we will consolidate the attendance and the feedback form, and we will submit it to ATAL for approval. As per the ATAL regulation, we need more than 80% of attendance, and I personally advise or request you to attend all the sessions without fail, even though it is given a benchmark of 80%. I request you to attend all the sessions. And at the end of the day, ATAL will generate a central feedback form which will be circulated in the group as well as into your mail. And please make sure that you have completed the ATAL feedback form. You fill the ATAL feedback form, which will be generated only at the end of the day. So by giving your feedback, your name will be registered in the final participant list. Apart from the day-to-day presence, day-to-day attendance, your final feedback attendance will also record into the ATAL server, which will enhances or which will help you to get the certificate without any hindrance. So this is the normal procedure of ATAL faculty development program. And now at the end of the day, we will give you a question answer multiple choice Google form. You have some takeaways from the 5-day faculty program that will be based on some basic questions and some takeaways from the FDP. And you have to attend the quiz or what we call as examination, right? I don't want to get you in trouble. It's not an examination. It's a kind of platform you can mention your takeaways. That's all. And as per the ICT regulation, we have you have to acquire 60% of marks in the examination. Please don't confuse with the examination. Don't get feared, because it's a multidisciplinary program. There are participants from many other disciplines, like we have engineers, we have technicians, we have experts from photonics, we have lasers, experts from lasers. So it's a general instruction. Be in the meet and just listen to the things what the experts are talking. So by this we came to an end. Dr. Smagul, are you there? Dr. Smagul?
Dr. Smagul has just left the meeting.
Okay, fine. So can we?
Okay, now the next session starts. Okay, thank you, Sunesh. So next session starts sharply at 2 p.m. So participants are expected to be present by 1:45 so that we can conduct the program very smoothly. So the same link is provided. You can enter via the same link. There is no separate link. You can utilize the same link that has been provided in the group. Join, and just like we have joined in the morning session. Okay, so in the next session, we are having Dr. P. Pradeep. He's a professor from NIT Calicut, who has been specialized in organic solar cells and condensed matter physics. So you'll have a very good session on the afternoon. Okay, so we can see in the afternoon session. Okay, thank you all.